States of matter. There are solids, liquids, and gases. To learn about the way gases are supposed to behave, we have to look at the kinetic molecular theory. This theory, if followed perfectly, forms an ideal gas. This gas is unrealistic. Gases consist of particles that are always in continuous rapid motion. These particles are spread apart across a large area. Collisions between gas particles and the container they're enclosed in are elastic. This means that there is no loss of kinetic energy. The energy is transferred between the particles during the collision. There is no force of attraction between gas particles. The temperature of gas also depends on the average kinetic energy of the particles of the gas. Let's first talk about expansion. Gases have no definite shape or volume. If you put them in the container, they'll fill up the whole container. Now, fluidity. Because attractive forces between gas particles do not exist, the gas glides past one another, like when you're pouring a glass of water. Low density. The density of gas is very low. It's about 1/1000th the density of the same subject as a liquid or a solid. This is because the particles are very far apart. Compressibility. Gas particles can be pressed together. This just makes the gas more crowded, and the given volume of gas is greatly decreased. If you compress the gas particles enough, it can actually turn into a liquid. Diffusion and effusion. Diffusion is when it's called the random motion of particles. It's like the spontaneous mixing. When you have gas, you don't even need to stir it to get it all together. It just automatically does that on its own. When effusion is the process in which gas particles pass through a tiny opening. It's like if you have a little hole in your water bottle and the water bottle is empty, the gas particles will just move in and out. Now we're going to talk about liquids. Liquid has something called surface tension. This is when the liquid surface is attracted to each other. This decreases the area to the smallest possible size. Surface tension is the reason why if you jump off a very high diving board, it can hurt. This is also the reason why some bugs can walk on water. Something that is very similar to surface tension and has to do with liquids is the capillary action. This is the attraction of the surface of a liquid to the surface of a solid. This is why if you have a test tube, you can see a dip into the middle because the liquid is attracted to the sides of the test tube. Now we are going to look at solids. Some properties of solids is that solids, the particles in solids are very close together. They vibrate. Unlike the particles of gas and liquids that are free to move around. Solids have a definite shape and volume. They also have a definite melting point. They have a high density and incompressibility. Oh, and they also have a low rate of diffusion. Now we are going to talk about changes of state. Let's first learn some of the names for changes of state. A solid to a liquid is called melting. A solid to a gas is called sublimation. A liquid to a solid is called freezing. A liquid to a gas is vaporization. A gas to a liquid is condensation. A gas to a solid is deposition. As an example of this, let's look at water and see how it changes from ice to a liquid to gas. Take ice for an example. If you take solid ice and add heat, it then turns into a liquid. If you add enough heat, you can turn that solid into a liquid. Water. If you add even more heat, that water can turn into a gas, and it's gone.